Hi friends, a warm welcome to you all. So we are learning pharmaceutical analytics and we are at the fourth day, fourth day of pharma or pharmaceutical analytics. Pharma or pharmaceutical analytics, where we have been discussing about for the past 3 days regarding this, where we covered a lot of things in this. First day, we have seen some applications and all these things. Then we have entered into the things, right? So first day, with some examples, the applications are being taught to you. Then we have been discussing about, okay, first day, applications of pharmaceutical analytics. Then on the second day, we have discussed about CRISP MLQ. CRISP MLQ methodology. CRISP MLQ methodology is nothing but a cross-industrial standard, process from machine learning. Cross-industrial standard from machine learning. Then on the third day, we have been discussing about, here we have some 6 phases in it. In the 6 phases, phase 1 speaks about data and business and data understanding. Phase 2, we discussed about data pre-processing. And on the third phase, model building. Fourth phase, we have evaluation of the model. Fifth phase, model deployment. Then the last phase we have is monitoring and maintenance. These are the 6 phases which we have learned as of now, right? Okay. So once we complete the model building, we should not stop there. We have to move forward and we have to complete the remaining phases as well. That is monitoring and maintenance, where that takes place in a very important manner. So we have to do monitoring and maintenance is important. Fine. Then this is the thing which we have seen with the second day. Then third day, we started discussing about the EDA, exploratory data analysis. In exploratory data analysis, we have seen all data types first. We have seen all data types. Data types in it. All the data types we have, whatever we have discussed that. Then in this data type, we have discussed about continuous, discrete, continuous data, discrete data. Then we have been discussing about categorical and nominal categorical data. That is almost considered discrete data. Then we have discussed about nominal, ordinal, ordinal, interval and ratio. Interval and ratio. We know that out of this, the nominal is the least preferred data and ratio is the most preferred data. Okay. Now the most preferred data is ratio data. We know that. The most preferred data is ratio data. We know that. I hope we understand. The least preferred data is nominal data, as we have discussed it. The least preferred data is nominal data. We have been discussing it as well. Now, and we know that interval is subjective, ratio is objective. Then we have discussed about quantitative, qualitative, then we have been discussing about structured, unstructured, semi-structured, structured, unstructured, semi-structured. Data. Then we encountered about balanced and imbalanced data. We know that balanced data is a data where both sides it is greater than 30. That is 30%. Right? We know that. If any one of the, if we take any one of the column, if any one of that value is greater than the more than 30th%, then it's called as a balanced data. Imbalanced data, which is less than 30%. Imbalanced data. So all these things we have discussed about the data types, and we have also discussed about cross-sectional data, time series data, cross-sectional data, time series data. Then we have cross-sectional data, time series, the panel and longitudinal data, panel or longitudinal data. This panel or longitudinal data, we know that it will have both the properties of cross-sectional and time series data. So first, what is the cross-sectional data? We have known that. So in cross-sectional data, In cross-sectional data, right, we will not give importance to time and date. Sequence is also unimportant. Sequence also unimportant. Time and date is not important, and sequence is also not important. Multiple column data. Multiple column data. It should have multiple column. But contrary, we have time series data where single column is important, where time and date are important. Sequence is also important since it is a time series data. So the property of panel and or longitudinal data is nothing but it will have multiple columns, and it is the time and date is important. Time and date is important. Time and date is important. Fine. So this is about the data which we have discussed. Then we entered into the exploratory data analysis part, where we have seen most of the pre-processing steps. Whatever we have, the pre-processing steps we have covered on that. Maximum pre-processing steps have been covered. Then outlier treatments, typecasting, discretization, all this comes under the exploratory data analysis. Then we have discussed about all these data type and text mining also. Textual data, how to create it. Text data, how to create it, how to delete it. That pre-processing tokenization, stemming, lemmatization, all these things are coming into picture. Stemming, lemmatization, everything is coming into the picture as we have discussed. Right? Those are the things which we have discussed here. Next one. So we covered till that with an example as well. We have seen with an example, we have encountered it and we have seen it clearly. Now, this is our fourth day where we are going to discuss about, this is our fourth day where we are going to discuss about unsupervised learning. We have also discussed about what is supervised and what is unsupervised, right? I hope that we have discussed it, the supervised and the unsupervised. Here, unsupervised learning is nothing but we will not have an output variable. no output variable will be there. No output variable will be there. Okay, that is unsupervised learning. So whatever the data that is not in the structured format, unstructured format, so we are doing with the unsupervised data. Today in unsupervised learning, we are going to discuss about K-means clustering. K-means clustering. Where we are going to discuss about K-means clustering. Right? Fine. Now, K-means clustering. What is the goal? First point, we want to learn what is the goal of the algorithm. Anything we took it, what is the goal? First point to be noted. The goal of a K-means clustering is to minimize the within sum of squares, minimize the within sum of square distance, and maximizing the between sum of square distance. Sum of square distance. So minimizing the between sum within sum of square, maximizing the between sum of square is my goal here. What is the sum of square? I will explain you all the things. I will explain you clearly. Now, this is come under non-hierarchical clustering. Non-hierarchical clustering. There is a difference between a hierarchical clustering and non-hierarchical clustering. What is the difference? What is the difference between them? Non-hierarchical and hierarchical. Right. So, hierarchical clustering, we have dendrogram. Before dendrogram, agglomerative and decisive clustering, we can say. Top-down approach, bottom-up approach, we can say. Agglomerative clustering. Then decisive, we have decisive. Diana, we can say. Diana, we can say. Right? Diana, we can say. Fine. Now, this hierarchical clustering provides the dendrogram here. Dendrogram here. Did not provide the dendrogram. That is the drawback of hierarchical. No, hierarchical clustering provides the dendrogram. What the dendrogram have? What the dendrogram have? Dendrogram have will give the number of clusters. Dendrogram will give the number of clusters to be noted. Now, let me see. If I have a large number of data, if I have a large number of data, then dendrogram will not give the good result. dendrogram will not give good result. That means we cannot interpret the number of clusters. We cannot interpret the number of clusters in dendrogram. Fine. In dendrogram it is. If the number of clusters is not when that, which means it is in the clustered format. It will be like in the clustered format. We cannot find the number of clusters here, how the clusters is formed and how many clusters are there. Using the line method also we cannot find. So the non-hierarchical came into the picture, where K means clustering. Here we will upfront we have to decide the number of clusterings. Upfront we have to decide the number of clusterings. Where here? Upfront we have to decide the number of clusterings. How we can decide a number of clustering without knowing it? That is a question I have. You are saying that, okay, upfront we have to decide the number of clustering. How we can decide it? So there are some rules. The first one we have is a thumb rule. The thumb rule is like root n by 2. Root of n by 2. Thumb rule is root of n by 2. That is a thumb rule. Okay. N is a number of records, number of rows, and 2 is the divisible. Now, let us say my records are 200. My number of rows are 200. So root of 200 divided by 2. Here we have some 100 value. Root of 100. The value is 10. So thumb rule is the value you get is 10 here. Okay, fine. Then we have scree plot. Then we have scree plot to decide. Scree plot will have x-axis and y-axis. Where x-axis have number of clusters, y-axis have inertia values. That is within sum of square, total sum of square, or between sum of square values. I hope it is clear. Please have a look in this. Now, how to choose the number of clusters? Let us say number of clusters is 1. What will happen? When k equal to 1, what is going to happen? When k is 1, that means only one cluster is there. That means only one cluster is there. Only one cluster is there. Only one cluster is there. Okay. So when this one cluster, what we can do? I will take the centroid here. Let me change the color. I will take the centroid here. I will take the distance between the points here. And after that, I will take the sum of it and I will square it. So this is a total sum of square value. Sum of squared value. Total sum of squared value. Fine, this is k equal to 1. Now when k equal to more than 1. More than 1. Okay, let us say k equal to 2. Now this is my cluster, first cluster I have. Anything, okay. Now, this is my one cluster and this is my, sorry, that should not be overlapped, sorry. And this is my one cluster, okay. Now a centroid will be there and we'll take the distances for this first. This is going to be within sum of square for this A cluster. Within the sum of square, within the cluster itself, what is the sum of square? Then here in this cluster, take the data points like this. This is within sum of square B. This is B cluster, this is A cluster. Now within sum of square A plus within sum of square B, which is equal to total within sum of square. Total within sum of square. Okay. Total within sum of square. I hope it is clear for you. Now, you know what is within sum of square or what is between sum of square? Let us say this is one cluster and one cluster. So the ultimate target here is to make, okay, the ultimate target here is like the distance between the two clusters, the distance between the two clusters, distance between the two clusters should be high. Now let me choose this. This distance should be high. Okay. This is between sum of square. This is between sum of square. Sum of square. This is within sum of square. Here within sum of square should be less. Within sum of square should be less. Less. So which means my objective of K means I stated the goal, reduce the within sum of square, which means the cluster should become small, and denser cluster should be there. And the other one should be at a longer distance. So this is my objective. So I hope the objective is clear to everyone here. I hope it is very clear, the objective, right? We don't want to confuse with the objectives here. Fine. We have a score called Ciliat. So I say that root of n by 2 is the thumb rule we'll use. Then scree plot we'll use. Then we will use Szilard score. Szilard score. Szilard score. What this Szilard score will do? What this Szilard score will do? Szilard score value varies between -1 to +1. Silhouette score value varies between -1 to +1. Okay. So for which k value, the Szilard score, the best Szilard score when it is high. So greater the Szilard score, better the k value is, which means you should select a Szilard score with this k value that the Szilard score of this k value corresponding k value should be high. Szilard score should be high, right? So I hope it is clear. So this is the rule. There is no other way to detect it. This is the ways you can find the k values. Fine. So okay, using the k values. Okay, using the k values. Let's say I found out the k is equal to 3. That is my best 3. Let us assume. Okay, let us assume that this value is my best value. Now, we know that this is the best value. Now, we will form this many centroids. Let us say my data points are here. And okay, now the distances. This may come under. Now this is my centroid. Okay, first time we'll take a random centroids. First time we will take a random centroids. The centroids will be random. Fine. First time the centroids will be random. I'm taking k equal to 3. So 3 centroids I'm taking random. Now from this centroid, I'll take the distance between all the points. Similarly, from this centroid, distance between all the points will be taken out like this. So like this, it will connect. After this, the cluster will be formed out. So now this is a cluster. This is a cluster. And this is a cluster. After choosing the randomized value and doing all these things, I got the value. Now by taking the average of this value, adding square, and I'm getting the average out of it. The new centroid will form. A new centroid will form. Centroid will come. Now from this new centroid, the distance will be calculated again. The distance will be calculated again and again. Again. The distance will be calculated again and again. Now from this, all these points. So now the data points will change. Now a new cluster will form again with the data points. So now this is my point. Okay. Now a new cluster is formed. Now again, taking the average out of it. Similarly, if you do the similar process, at one time, the centroid will not change. At one time, the centroid will not change. At one time, the centroid will not change. Now you can see the cluster become denser and denser and denser. And the distance between the two clusters are changed. The distance are high now. And the centroid here is stabilized. The centroid here is stabilized. It is not changing. By this time, you need to stop. Your clustering is formed. By this time, your clustering is formed. You need to stop. Fine. Now, you know that by this time, we have to stop it. Repeat the same process until the centroid doesn't change. Now, for stability purpose, run the k-means clustering. Run the k-means clustering. Sorry, k-means clustering. Multiple times. For stability purpose, run the k-means clustering multiple times. Called as iterations. We will call as iterations. How many iterations there can be? Okay, run multiple times, then create a new centroid. Create a new centroid out of it. Sorry, run multiple times with randomly chosen k values. With randomly chosen k values. Fine. This will address the multiple local minima values. What is local minima? This will address the multiple local minima values. Let us say this is my, now my point can fall here. My k value can fall here, Either here my local minima will be there. Here my local minima will be there. The minimum of the local minima is called as global minima. The minimum of the local minima is called as global minima. Fine. The minimum of local minima is called as the global minima. Wonderful. Now, while doing the iterations, it will come first iteration, second iteration, third iteration, maybe it reaches the point. So that is why we will do the multiple times to get a multiple, to address the multiple local minima values. Then there is another catch also. Let us say we have a data point like this. The distance between this and this are similar. So when a data point is at the same distance for two clusters, then what will happen? Then it will keep on oscillating. My algorithm keeps on oscillating. It will not stop. It will keep on oscillating, right? Fine. I hope it is clear here. My algorithm keep on oscillating. Wonderful. Okay. I hope that you are clear until what we have discussed as of now. Now, this is fine. There is a convergence criteria that my centroid will always not be stabilized. So I'm saying a convergence criteria that is 2% to 5% can be there. 2% oscillation and 5% can be there. This is my convergence criteria. This is my convergence criteria. Okay. After this, we have to compare between clustering, that is between sum of square clustering and within clustering. We have to compare all these two things. We have to compare between sum of square clustering and within sum of square clustering. Right. So the between sum of square should be high, and within sum of square should be less. Between sum of square should be high, and within sum of square should be less. I hope you are clear. So we have to choose the K value. We have to choose the K value with less within sum of square and high between sum of square. With the less within sum of square and high between sum of squares. I hope it is clear. With less within sum of square and between sum of square should be high. Fine. Now, there is a drawback. There is a catch. K means is sensitive to noise data. That is, K means is sensitive to noisy data. That is outliers. Instead of K means, we can use K medians. Instead of K means, we can use K medians. Since we know that K median or median is not influenced by outliers. Is not influenced by outliers. Is not influenced by outliers. Right? We know that, right? Since if I say 1, 2, 3, 4, 5, and 100, if I take the mean of this, the mean is like 1 plus 2 plus 3. 1 plus 2 plus 3 plus 4 plus 5 plus 100 divided by 1, 2, 3, 4, 5, 6. If I take this thing, so 3 plus 3, 8, sorry, 6, 6 plus 4, 10, 15, 100, 115. 6. If I get a value, the average is going to be something around 25, let us say. But the average is not 25 here. We know that. 1, 2, 3, 4, 5. Only one value here. that is 100, only one value here, that is 100. Because of this one value, our total column or data is getting affected. So we know that mean is influenced by outlier. Mean is influenced by outlier. I hope it is clear. Whereas median is not influenced by outlier. How? Median will take the middlemost value, 1, 1, 2, 1, 100 now. Okay, let us see. Now, first median will try to arrange it in the ascending order. 1, 1, 1, 2, 100. Arrange in the ascending order. After arranging in ascending order, it will take the middle value. It will take the middle value. Here it is 1. Influenced, not influenced by outliers. Not influenced by outliers. I hope it is clear. Why it is influenced and why it is not influenced. All right. Right. The same way, K-medoids we have. K-medoids. K means K-medoids also there. Right? K-medoids. When we have a categorical data, let us say, now, when we have a categorical data, we use K-modes, fuzzy K-modes, K-prototype. When we have categorical data, K-modes, fuzzy K-modes, K-prototype. When we have mixture of categorical, so when we have a categorical and numerical data. Okay, fine. We will use K-modes, fuzzy K-modes, K-prototype. Now, when we have a non-convex, let us say convex. This is my data cluster. Okay. Then the outer cluster, let us see like this. Right? It is like this. Let us see. Like this, I will say. Now, if I take the value here, if the clustering is done, K means it will do the cluster like this, right? One cluster and other cluster. One cluster and A cluster and B cluster. So the shape is circle, but it's showing a cluster in different. That is wrong, right? So these kind of problems can be done with K means plus plus or intelligent K means like that, right? So this is the basic and the uttermost important about the K-means clustering. I gave all the idea about the K-means. And when I have this kind of clusters, let us say, when I have this kind of clusters, K-means will give me like this. So that is the drawbacks of clusters. Now, in medical forum, how the clustering is formed and how it is using. So machine learning in pharmaceutical industry. Improving medical diagnosis, better patient care, improving medical diagnosis, better patient care, predicted the next pandemic, combating the cancer, drug efficient detection. We know that improving medical diagnosis, what it is, better patient care, we know, predicted the next pandemic, what is the COVID and what happened in the past and how it happened and what is going to happen in the future and how we are going to safeguard that. What are the precaution steps that we are going to take on all these things come under the pharmaceutical analytics. Now, unsupervised learning example. So unsupervised learning is a machine learning technique, in which models are not supervised using a training data set. Unsupervised learning is a machine learning technique in which models are not supervised using a training data set. Instead, models themselves find the hidden patterns. So in supervised, mathematical equations will be formed. Mathematical equations will be formed in supervised. In unsupervised, mathematical equations formed. In unsupervised, we will have patterns, or rules, patterns like that, or rules. Here the rules or patterns are formed out of it. Clear? Supervised and unsupervised. I hope it is much clear. And insight from the given data. It can be compared to learning which takes place in the human brain. It can be compared to learning which takes place in the human brain while learning the new things. While learning the new things. That is fine. While learning the new things. While learning the new things. I hope it is clear now. Fine. The goal of unsupervised learning, is to find the underlying structure of the data set. The underlying structure of the data set. Group that data according to the similarities. Group that data according to the similarities and represent that data in a compressed format. Represent that data in a compressed format. Okay, is to find the underlying structure of the data set, group that data according to the similarities, and represent that data in a compressed format. The resultant group or cluster will have low variance. So this is the cluster which we have discussed. Right? You can see here, input I gave some tortoise, fishes, ducks. Put the algorithm it's showing ducks separately, this separately and this separately. K-means clustering. K-means clustering is one such unsupervised learning method that aims to group similar data points in cluster. It allows us to cluster the data into different groups and a convenient way to discover the categories of groups in an unlabeled data set on its own without the need for any trainings. It is a centroid-based algorithm. As we know, where each cluster is associated with the centroid. The main aim of this algorithm is to minimize the sum of distance between the data point, and their corresponding clusters. Sum of the distance between the data point and their corresponding clusters. Clear? Have a look. Hope it is clear. Now, initialize the centroid K, first step, as we know. For each sample in the sets of samples, assign sample to its closest cluster K based on the Euclidean distance. We have Euclidean distance, Manhattan distance, Mahalanobis distance. We have Euclidean, Manhattan, and Mahalanobis distance. Yes, we have. Assign sample to its closest cluster K based on the distance. For each cluster in the sets of clusters, for each cluster in the set of clusters, recalculate the cluster centroid based on the mean of the samples in the clusters. Repeat the step 2 and 3 until a stopping criterion is fulfilled. Until a stopping criterion is fulfilled. Determine the variance of each cluster and sum. Determine the variance of each cluster and sum. Repeat steps 1 to 5 with different initialization of the cluster centroid positions times n int times. Now, some of the advantages of k-means clustering here listed below. Here, k-means is the most used clustering method, largely due to it being computational inexpensive. It is not that much expensive. It is computationally inexpensive. K-means is computationally inexpensive. It can scale well in large data. That is the actual drawback in dendrogram, right? In hierarchical, small data points are done. Large data point cannot be, right? Similarly, the same way here. Same way here. It is an appropriate method when you know the number of clusters to be drawn from the data set. It is a perfect method when you know the number of clustering to be drawn. I hope it is clear. Limitations. Number of clusters must be chosen upfront. Fine. Outliers can have a strong influence on results. This is very bad. Initial centroid positions have a strong influence on results. Does not cluster well with clusters of varying size and densities. Does not cluster well with clusters of varying size and densities. Of varying size and densities. Right? Done. Key concepts we learned. For stability run, the k-means clustering multiple times can be iterated with the different random chosen k values. This will address the multiple local minima values. The data point might keep oscillating two clusters between the two clusters in each of its run, and the algorithm will enter infinite loop. Address this by choosing convergence criteria or by specifying maximum number of iterations. Specifying maximum number of iterations. I hope it is clear. Convergence criteria is a stop when a cluster centroid moves less than a certain percentage of smallest distance between any of the centroids. Compare between the clusters. We have discussed all these things. Typical objective is like that. So this is about the k-means clustering. Let's quickly see the, let's quickly see the coding part here. As last class we have seen in Jupyter Notebook. Let's see this one in Spider. Okay. It's opening. It's like a little bit time, you know, but it's somewhat quick, right? Now, let me show my data set for you first. Let me show you my data set for first. Fine. I don't think it is there. Yeah. I have my data set here. So this is my data set. Approximately there are to 20,646 records are there. Okay. And how many features are there? We have around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 features are there. 10 features are there. Opening it. Now let me run the, I am importing the required libraries here. We know that NumPy is for numerical calculation. NumPy is for numerical calculation. SciPy is for scientific calculation. Scientific calculation. Pandas is for data frames, manipulation of data frames. Data frames. We have TensorFlow, Keras, all these things, and that comes for the deep learning part. We have Matplotlib, Seaborn, Plotly. All this comes under the data visualization libraries. So all these things we know. Now importing the required libraries, I'm importing scikit-learn.cluster. From that, I'm importing k-means. I'm running it. It's showing that no module found. Scikit-learn. I think I have run the first one. Now I run it. Now I'll run it. No module named sklearn. Okay. Fine. Let it be. Let us run this. Okay. One moment. Let me import that. Pip install sklearn. When I run this, it will run for a while. It's running. It will give me the answer. Now it ran. Now I can run the, it's saying still the same. Clusters k means is done. Okay, now it's run. Yeah, now it ran. Similarly, I'm importing the pandas data frame, and from that I'm importing the library here. Once I opened, I can see that this is my data set, which I shown you previously. Fine. Then I'm saying that if anything is, please drop it and run it. Then Pharma2 dummy values, get the dummy values and drop first the dummy values. I'm running it. It dropped the dummy values. So these many dummy values are there. Then we have, I'm saying that in place is equal to non-medical amount investment. I can run it and it will drop that things. Then I'm saying that wherever the minimum value, I'm just normalizing is using the normalizing function, using it. And this one also I'm using it. Then df norm is equal to normal function of pharma and df norm. We know that total within sum of squares is this TWS is then K range I'm giving. Then K means the clustering is imported. And scree plot is given plotted. Scree plot is plotted here. And if you want to see the figures, you can see here the scree plot is there. The variable explorer. Now the model dot labels. Then like this, if you can see that the data is done here. Right. So this is about the clustering part. So I hope that you have liked the video. So tomorrow we will be seeing the 5th day, day 5 of our session. Day 5, where we are going to learn a lot with a new algorithm with a good use cases on it. I appreciate that your patience. Please subscribe to our YouTube channel. Please subscribe to our 360 YouTube channel, 360DigiTMG YouTube channel, and bell icon also press it. Please follow us on LinkedIn as well. LinkedIn. We have a person called Bharani Kumar Zapuro, who's the CEO of our company. He's having 17 plus years of experience in it. Yeah. So I hope that you can watch the Python videos of him, Python recorded videos of him as a beginner if you are. So thank you very much. I hope I made your day. Have a great day. Stay safe.